everyone. Welcome to my YouTube channel. I am Debolina. In today's video, we are going to take a quick and simple look at one of the most powerful and foundational programming languages, that is the C language. We'll explore some important topics here, like what C exactly is, a brief history of how it was developed and evolved over time, like the features of C language and how a C program works behind the scenes from writing code to its compilation and execution process. So, if you are new to programming or want to strengthen your basics, you are absolutely in the right place. So, let's get started. Let's start by asking a simple question. What is C? C is a general purpose procedural structured programming language. It was developed by Dennis Ritchie in 1972 at Bell Laboratories. You can think of C as the mother of many modern programming languages like C++, Java, and Python. What makes C powerful is its simplicity and speed. With C, you can do both simple level programming like writing operating systems and application development like games and tools. It gives you a direct control over the hardware, which is why it is still used in embedded systems, operating systems like Unix, and even microcontrollers. Now let's move on to this part. Now in this part of the video, I'll be talking about the history of C language. Honestly, it's not that important from a programming point of view, but since some colleges have it mentioned in their syllabus, I'm covering it briefly. I'll explain it like a short story so it becomes easier for you to understand and remember. Also, I've given the explanation in the form of presentation notes so you can use it as reference and write it in your exam if needed. Okay, so now let's begin with the history of C. The C programming language has a rich and interesting history that begins in the early days of computing. Back in the 1950s and 60s, programmers were using assembly language, which was very hard to write and understand. To make things easier, high level languages were developed. One of the first was Fortran in 1957, used mainly for scientific calculations. Then came ALGOL 1960, which introduced structured programming concepts. In 1966, a language called BCPL, Basic Command Programming Language, was created by Martin Richards for writing system software. This inspired Ken Thompson at Bell Labs to create a simpler version called the B language in 1969. It was useful but had many limitations. It didn't support data types, for example. Then came the breakthrough in 1972. Another Bell Labs programmer, Dennis Ritchie, built upon B and created the C language, added to the important features like data types, structures, and pointers, making it more powerful. The main reason for creating C was to write the Unix operating system, which was originally written in assembly. Once Unix was written in C in 1973, it became much easier to move it to different machines. This is called portability. This was a game changer and made C popular in system programming. As they gained popularity, it became important to make it standard so that programs written in C could behave the same way on any machine. So in 1983, the ANSI, American National Standards Institute, formed a committee to standardize the language. This led to the release of ANSI standard in 1989, also known as the C89. A later a year later, it was adopted intentionally by ISO becoming C90. Okay. Over time, the newer versions of C were released to add more features and fix issues. In 1999, C99 was introduced, adding things like inline functions and variable length arrays. Then in 2011, C11 came with better support for multi-threading and security. The latest standard C18 was released in 2018 with bug fixes and minor improvements. So this is a short summary of the history. Now let's move on to the next topic, that is why C became popular. Because of its portability, efficiency, and versatility. These three are the main causes. That's why C became popular. Now, a very important topic which often comes in the exam, like the features of C language. So, C programming language is powerful, fast, and flexible, which is why it's still widely used today. Let's understand its main features step by step in a simple way. The first is simple and easy to learn. C has a small set of keywords and a straightforward syntax. It's not overloaded with too many features, which makes it easy for beginners to understand and write code. You can do a lot using just a few commands. Okay. Now, the next is structured language. C follows a structured approach, meaning the code is organized into functions. This helps in breaking down a large program into smaller manageable blocks. It promotes clean coding and reusability as the same function can be used multiple times. Next is mid-level language. C is called a mid-level language because it combines the best of both worlds. It has features of low-level languages like direct memory access, pointers, bit-level operations, and also supports high-level programming like functions, loops, conditionals. This makes it suitable for writing system software like operating systems as well as application software. The next point is portability, that is machine independency. A major strength of C is its portability. Programs written in C can run on different machines with very little or no change in code. This means if you write a program on Windows, you can compile and run it on Linux or Mac with small adjustments. Next point is fast and efficient. C is a compiled language, meaning the code is translated into machine language before execution. This makes program very fast and efficient. Also, since C allows direct interaction with memory, it gives better performance and speed. Next is rich library. C comes with many built-in functions provided through header files like stdio.h, stdlib.h, math.h, etc. These functions help perform tasks like input or output, memory allocation, and mathematical equations very easily. You can also create your own user-defined functions here. Okay. The next point is pointer support. One of the most powerful features of C is its use of pointers. Pointers allow direct access and manipulation of memory addresses. They are especially useful in arrays, strings, dynamic memory, and data structures like linked lists and trees. Okay, now the next point is the dynamic memory management of C. C allows you to manually manage memory. You can allocate memory during runtime using functions like malloc, callloc, and realloc. You can free unused memory using free. This gives programmer full control over the memory, which is very useful in large applications. Okay, so the next point is extensibility. Then C is extensible, meaning you can add your own features or create new functionalities easily. You can define custom functions and structures that make your program more modular and maintainable. The next point is compiler based language. C is not interpreted, it's compiled. Using compilers like GCC, Turbo C, or Clang, this compilation process turns the source code into fast, optimized machine code that your computer can understand and run clean. The next point is recursion support. C supports recursion, which means a function can call itself. This is useful for solving problems like calculating factorial, solving puzzles, or working with data like trees, graphs, etc. Now, the last point is low level operation. With C, you can perform low level operations such as accessing and manipulating individual bytes or bits of data. This is useful for writing device drivers, compilers, and embedded system programs. Okay, so this was our features of C language. Now, a very important topic which almost comes in every exam, which has C in their syllabus, that is the compilation execution process of C. So I have given the step-by-step processes like what comes after what. First, the source code, preprocessor, compiler, assembler, linker, loader, execution. I'll be explaining each and every point in detail. So first, let's start with the introduction. Like when we write the program in C, we are simply giving instructions to the computer using human readable code. Computer cannot understand this code directly. It only understands machine code, which is binary. So the process of turning our .c file, that is a source code, into an executable program that the computer can run involves several steps. Let's understand each step one by one in a very easy way. So our first step is writing the code. So we begin by writing our program in a text editor like Notepad or an IDE like Code Blocks or VS Code. This program is saved with a .c extension. For example, if we write a program to print hello world, we save it as hello.c. This file is known as the source code. Before compiling, the program passes through the preprocessor. This step handles lines that begin with hashtag, like hash include stdio.h or hash define pi 3.14. The process replaces all macros and includes the content of header files into your code. Think filling in blanks before reading a story. The result is an expanded code file, usually called .i file, example hello.i, but we don't usually see it unless we want to. Okay. Now the next step is compilation. Next, the expanded source is sent to the compiler. The compiler checks your code for syntax errors and translates it into assembly language instructions. This is a low-level language that is one step closer to machine code. The output of the stage is an assembly file, usually with a .s extension, example hello.x. S. At this stage, the human readable code has started transforming into a language the machine can understand. Now the next step is the assembly. Okay. Now comes the assembler. This tool takes the assembly code and converts it into machine code, also called object code, which is almost ready to run but not yet complete. This output is saved in a .o object file such as hello.o. However, if your program uses functions like printf, the machine doesn't yet know where to find those definitions. That's where the next step comes in, which is linking. The linker is like a librarian. It takes your object file and connects it to the necessary libraries that contain actual code for functions like printf, scanf, surt, squirt, square root, etc. Without linking, your program wouldn't know how to perform these actions. Once all the needed parts are linked together, the result is a complete executable file. Something like hello.exe on Windows or just hello on Linux. Now your program is ready to run. Now the next step is loading. Now the program is ready. A part of the operating system loads the executable into main memory, which is the RAM. This makes the program available for the CPU to execute. It sets up everything your program needs, like memory allocation, stack space, and variables. Now, the last point is execution. Finally, the CPU begins executing your program, starting with the main function. Each line of code is run one by one, and you see the output of your program on the screen like the hello world. I hope I am able to clear this topic to some extent. So that was a quick introduction to the C language, its history, features, how it works. In the upcoming videos, I'll be covering each and every small topic of C in detail, including both theory and practical demonstrations to help you truly understand how all works. And for those who feel more comfortable in Hindi, I have also made a Hindi version of the same video. You can find the description box below. You can find it there. So feel free to check it out. If you found this video helpful, don't forget to like and subscribe. See you in the next video. Thank you.